You have no idea how easy it is to create a spot trading interface from scratch with Injective. It is very easy. You don't even need to use smart contract. Let me show how in this tutorial. I am Zephyr, and in this video we're building a simple yet fully functioning trading interface on Injective protocol from scratch. Let's get straight into it. Before we continue, let's make sure you have everything you need. First, you make sure you have Node.js installed on your machine. Head over to nodejs.org and make sure you download Node.js on your system. The next thing you'll be needing is some basic React knowledge. If you are not familiar with React, you can head over to react.dev to learn more about it. Next thing you have to install is MetaMask. Install MetaMask wallet on your browser, and let's continue. So before you move forward, the full code is available on GitHub. I will be leaving the link on the video description, so you can clone the video, clone the code, and continue. So how are you using this tutorial? This tutorial can be used as a reference. Once you clone the repo, you can use the tutorial to understand the implementation of each feature. So let's continue. So how will this work? So let me explain the architecture. We'll be using React with Typescript to build the user interface, and then all the interactions with the Injective protocol will be using the Typescript SDK. We won't be smart contract. The main tools we'll be using is Injective Labs SDK-TS and the Injective Labs network with some React hooks and plain CSS. So let's get straight into building. So let's set up our React application. So you have to open up your terminal. I'm using PowerShell. I'm on Windows, but if you are on Mac OS or Linux, you can use your terminals also. So you have to use npm create write at latest, then injective trading. We're selecting React and then selecting TypeScript. No, we will not be using the row down with. No, we are not installing npm and starting now. So the project has been created. You see the injective trading, and then you are going to run npm install. So we've run npm install. Let's continue following the tutorial. So we have to install the Injective TypeScript SDK that allows us to perform actions on the blockchain without contract. So you copy the code from tutorial. Okay, so we've installed all the packages. Now let's get to the coding part. So to open this project in our code, I'm using VS Code on my machine. You can use code dot. This opens the tab, open VS Code in the file, and we can close our terminal. Let's close this also. Okay, so let's move this to the side and move the tutorial to the side. Okay, so we have our base React application. So let's get started by setting up our app structure by importing required packages and setting up the required interface. So okay, so it's gotten the required imports. So we've gotten the required imports and the interface set up. Let's update the main component to use the essential API client from the Injective. can open the terminal with Ctrl J or Command D if you are on Mac. Okay, so we just pasted the required import. Let me explain what we just imported. So we've imported the required packages from the Typescript SDA itself. Those are the DHCP endpoints and the Exchange API to make and place orders. And we've also imported some React hooks, use state, use effect, and use reference. So in the app components, we initialized each of the endpoints to use the testnet network. So indexer GRCP endpoint is used to get spot data and market data. The stream endpoint is used to stream the data to get real-time updates. The chain based balance API is used to get account details, balances, and the chain gRPC exchange API is used to actually do positions and trading positions. Okay, so let's run our application. So you open the terminal with Command J or Ctrl J, then you run npm run dev. So you copy the link and open it in your browser. Yay, our app interface is currently running. So let's continue with the tutorial. So next one we are going to do is setting up collection of wallets. So let's declare state variables. So we declare state variables for the wallet collection. The is connected, the addresses, the injective address, and error to catch errors. So next thing, connection logic. We'll be using the get Ethereum window because we are using EVM wallet to interact with the injective blockchain. There are different chains though, but EVM, but injective is EVM compatible. So that allows us to interact with the chain using any EVM wallet and EVM DApp. This is also a TypeScript interface for the window. This and that, the error is gone. Okay, so let's create the connect wallet function based on the code here. So this is connect wallet function, calls this function to get Ethereum wallet and performs this request account. From this request account, you get the addresses that is being returned. You map the addresses to the EVM addresses. EVM addresses dot map. You get the injective address. This is like so connect wallet function does this. The const Ethereum calls this function upper function that is being declared here. Then we do this request permission from MetaMask. Then we get the injective address from the list of addresses that is present on the this is like a default function that is being put into the get injective address is the big thing into the injective SDKs. So you can just do that and get the addresses that is being returned and console log it. Let's also create the disconnect function. This is basically just setting everything to false. Yeah, formatting the address. because an address can be as long as this, and we don't have to display that in the UI, so we don't have to truncate it to look something like this dot something similar. That's what this function does. Takes in the address, slice it, and alright, so let's work on the UI itself for the so we have the header. Here we have the header here. This is if there is an error, but for now the main will be displaying nothing else other than the address that is connected to. Okay, so this is what we have done so far based on following the tutorial walkthrough. So let me just quickly go over the code again. So we have this helper function here. This is Windows or Ethereum, because when you install MetaMask on your Chrome or your browser, it gives it gives the window this .ethereum function to call to do perform actions, so you do call that function, you do ethereum request, you call the method request accounts, you get the injective address from the account you returned from the request, and then set the state variables to that so that you can use it across the applications. So let's click on connect wallet. You see the MetaMask pop-ups, and then we can connect our wallet with it. Yeah, yes, so connect. Yeah, so our wallet has been connected. You can see the wallet here, the wallet address, truncated. This is what I mean by when you format it, because you don't want to have the long string displayed in the UI. That's something you know how to do. So let's continue. So we've tested it, approval, and like so. What next on our timeline now is for us to implement the wallet, the market rather, so we can fetch available markets on the blockchain for us to interact with. So if you notice, we declared some trading paid data earlier. So let me just declare the trading paid interface. This is TypeScript stuff. So the interface is kind of like the types of the data expected and what type they are. So now let's create another state to store this data here. So we have the so you have the selected pair. This is the selected market. The list, this is going to be an array of the trading pair that is being listed. This is a boolean to know if the market we are still trying to load or not, and this is if there is an error also. So yeah, so now let's create a function to fetch the market itself. So to fetch market, we'll be using the use effect. What does use effect does? Use effect runs whatever functions is inside when the when the component loads. Think of it like when the page load is, that's when it calls. You don't have to like make it to like wait or click a button for you do it, like auto does it when as the component is being mounted, it loads or call the function. So we're using use state to fetch market here. So we have use state function of fetch markets here. So we're using the indexer JavaScript and postport API to fetch market. So So this is mainly doing the work this year. It's highlighted line 103. This is doing the most of the work, fetching the data, and then we are just using the rest. We are using the rest to format data and display it well. So the formatted trading pair, we are mapping each market. Then remember the types you declared earlier: the market ID, the ticker, the base token. Yeah. So then we put it into an array which you declared also earlier. So use the drop down, and this is error handling. If there's an error, log console log it. So let's work on the UI for that also. So this is, we are going to be doing it in this main code here. The market UI selector. This function is going to change when the drop down is being selected, so they can know the current data pair we are trying to refer to in the code. Okay, so let's check what we did so far. Interesting. This is it here. So you've seen the list of markets here. Yes, you can see it here. List of active markets. We've getting the markets available. And mind you, currently we are using testnet. I forgot to mention earlier, because if you look at our code which we've written here, while we are initializing the endpoint, we set it to testnet. I'm not using mainnet. If you change it to mainnet, if you change it to mainnet, when the market loads, it loads mainnet market data. So that's just the likes of Atom, like I said, this and the likes. Okay. So for now, we stick to. So for now, we are going to stick to mainnet, testnet rather. Alright, so if we are able to get the market data, okay, so yeah, we are actually logging the data, but I don't have to show you the command because we've already seen the log. Yeah, so fetch markets, the market base token information, code token information, ticket price, DAO. Yeah. Alright, so we're able to connect wallets, fetch the market, connect your wallet, fetch the market, available market to trade on. Next, we have to create an order book. Fetch order book. Another book is the list of buys and sell that happen on the market. You should look at the apps like Elix or Bybit. They have another book for spot trading where you see the red, green on top, whether at the bottom, whether at the top, green at the bottom. So the list of trades as they're happening. So let's go ahead and build the order book. Okay, so uh For let me explain this. For the other book, since we are streaming data, so first we have to fetch the initial data first and then stream the data. I showed you streaming endpoints here on top of this thing here, stream, to stream the other book data as trades are happening on the blockchain. They are getting updated. Is that clear? So our other books, buy orders, sell orders, you know, most blockchains, like other blockchains, other DEX on blockchains, use this automated market maker formulas for trading. So the prices are determined, using some algorithm by trading liquid pools. So Injective has a fully on-chain order book that uses the same mechanism used by some traditional finances on stock market exchanges like NYSE and Nasdaq. So this gives traders like more control over their entry, their exit prices, better prices in general. So if you want to learn more about other books, you can check it up, and there's a link to the investor put your guide. So yeah, so first next now we are let's declare some states for the other books. So the data being included by the other book is not much, just the price, quantity, and timestamp of the markets. The markets. Okay, so yeah, another we're using another React state variable which is useref. Useref is use reference. It is using states. So when the data is being updated, we don't refresh the page to load the new data. Since we are streaming data from the other book, new updates are coming in. You don't want to be refreshing the page on each new data that comes in. So the user handles that. So next, we create the states for the normal state variables for the orders. So buy orders, sell orders. If the order is still loading and the coin price, use user to stream. So you also be using use effect to do the so this is a fairly large bit of code. So I will be going to each block so you can understand what it does. Okay, so all right, so with so this is the use effect to fetch the other book. So first we are checking if a pair has been selected, and if the trading pairs that have been returned there's no zero. Then we are doing the current market, which we use for the get current market data, which we declared earlier. It's just going to pick the current, the current pair that is being used. That is the market pair. That is the injective. This is a pair. This is a pair, which is using that. So we've checked those until there's no error, we fetch them. So we set the other book state to loading to indicate that it's loading. So what do we do first? We fetch the initial data, because in a case where we are using text where there is not much stream data, so the data might take time to get to us. So first we have to fetch the initial data, and then we can stream it into it. So this is the fetch initial data working on. Use the indexer just endpoint fetch order book version 2, put in the current market ID, the current market, the data we declared earlier while we are fetching the market, and then we console log the data in the order book. Then there's this process order book function here that takes in the order book and then sort it out based on the buys and sell. So process order the top 10 traders buys and sell. Same for the sales also. The streaming itself is also as basic to do. The injective SDK makes this very, very easy to build. So if to check out now, to do this stream now, all you just have to do is what? Do this stream function and start spot stream dot stream spot order version 2 dot bind, and do this. Then the callback, the stream callback here, order book share, process order book is just so easy to implement. Okay, so you do the stream dot current stream function, market ID, and then the stream callback. This is the stream callback. So once the data is being received, you do the function and process the data again. The cleanup function is just clean up order books, for residues. So this use state will only trigger if there is a change. Unlike the earlier use set we used, that doesn't have a doesn't have anything in this area. This is taken in data. So that means if these two data changes, the use effect will run again. So that's how we are able to fetch new order based on new pair being selected. Is that okay? So let's go back to the UI. So fetches the new data, processes the data, the streaming, calculate the prices, and cleans up. So we also have this helper function here. This is a fairly large code. This is used to for market data. For market data prices that are longer, like 0.0000000 this. So to display this in the UI of the app doesn't initially sound smart. So we're using this subset. If you check on the screen out some trading, you have the use subset. I will show you how it looks like in the UI. So let's have the function to format the pricing. Use subsets. Subsets are like tiny versions, subscript rather, they are like tiny versions of the actual number itself. Get code symbol. So INJ USDT. Now let's work on our order book. The order book UI. So undo price click here. The set price should also be here. So once you've gotten the UI set, you should have another book similar. Yes. So now we have the other book here. So we should go to so you see the other book is being fetched. So you've gotten the other book column to the side here. So next thing we have to do is have the trading form where users can place their buys, their sells, and the likes. Okay. Find types and state variables. The other type on the other side can only be one of these. Either you are buying or selling, or they are trading in market or in limits. create another set of state variables to handle other side and the we having small helper functions to help calculate the total cost of an order. Another use effect functions change from values. Declare the previous if there are error messages since they change the values, so you also have to clear put that also. Alright, so now let's build our trading column. So we have a div, there's a class name, I'll put this UI in it. Now we are going to declare the functions later on. So there will be errors now. You're going to declare the functions for the. Let's call this out for and sorry. Okay, so we have this market order limit price, market order limit price. There's some comment on the bottom and implement the functions for placing the order itself. So let's actually place order sign, and this is very cool, start getting bulky. So please try to go to the code itself so you can see what exactly is being used. So I'm going to import more independent dependencies from the Injective SDK block Typescript. Okay. To discard the errors you are seeing now because they are not being used. We will be using them as we are placing using them as we are placing orders. Okay, so let's have state variables. State variables we declared earlier are for keeping state values. So okay, so let's start. This is where the project start getting bulky. So first fetching the account details. The account details is like getting the account number, the sequence number of the account that is performing the transaction that we can use, so we can use it in the handle order and signing transactions. So we are not fetching the user balance yet. Let's comment this out. User panel, we don't have it yet. Uh-huh. See, this is what I meant by the subscript. That says, so you have to list the entire 8 zeros. So now let's display the handle place order functions. The handle place order functions here. Check if the quantity being returned is not empty. Check if the wallet is connected. If the correct market has been selected, then validate. So if the user wants to place a limit order or a market, so we are currently working on the limit order now. So these configurations, we get the market data from these data are still from the market data we fetched earlier during the video, the markets okay. So configuring the market data, so because the blockchain is usually responding in large number of integers, so users have to see the decimal values of the required stuff. So now the sub account ID, sub account I think of it like the like your address, but with that trading accounts. You will create a Bybit account. Usually sub account created for traders. So now let's create the actual order messages. Is for limits. So we have the order type. If the user is buying or selling, the free recipient, the address of the person placing the stuff, we use this to convert the data to human readable format. This is where this function is used to create the orders itself. The message create spot limit order from JSON data, sub account ID, the injective address, the order type, one for buying, two for selling, the price which the user wants to place the order, the quantity of buying, the market ID which the user is wants, or if they are placing the market stuff, still same thing. I've imported necessary stuff. This is next one where I'm handling the transaction signing, because once they've created the order, the user has to sign it with their wallet for the transaction to goes to. So chain ID testnet, the EVM ID, since we are using an EVM wallet to interact with the injective blockchain, We are not building on Ethereum, but because Injective is multi-operatable to different blockchains, currently we are using the EVM to interact with it. So the account number we fetched earlier, created transaction blocks, the EIP712 data format, so the users can actually see what they are requesting and sign in with their data. So once they've done that, we call the Ethereum function we declared earlier, request the signature from the user's wallet, then get the data, their public key, signature, preference, use it to create transactions. Because we are use it to create this transaction, the Cosmos execute transactions, use it to create the transactions. We request the signatures, create the signature and passing the signature which we signed from this user earlier here, the EVM, because we are not bidding on Ethereum. We are just using Ethereum wallet to sign the transaction and then send transaction to Injective blockchain. So final part of the code is to clean up the data. So this is once the transaction has been done, clean up the data, empty data we don't have to save. So we are not fetching user data balances now. We'll do that later. Next, we are going to have a way of fetching the user accounts. That is the user balances, their sub accounts, positions, and other. Okay, so let's then account states. So get the function to fetch balances. This is doing the most of the work. Chain bank API dot fetch balance the injective address. The rest of the code is just formatting, trying to format it to email readable format. This is mainly the code for fetching the balance. So another code to fetch the user positions, that is their placed order. If they have any trading order open, you can check it. So the main code doing the issue, the code is here. So we get the account ID, all the account ID of this, then we fetch the first sub account order list of the account ID. Then you use the position, full position, first positions, then you try to filter out based on the sub account ID. So then the user panel. So with that, we should have concluded the finally. So, and with that, our final app code, the final UI should look like this. So you just connect the wallet. Then we have the order book, our trade, You can place order, show it here on the MetaMask requesting, so for users to sign it, and then they can. Alright, so thank you for going to the video with me. So I would please go to the tutorial so you can check it as it is and try to understand it better. If you have any issues, please drop any issues you have in the comments.